Rita Qawl, Director of Education at Challenger Center for Space Science Education. Today's guest is Dr. Alan Stern, and our subject is the interesting moons of Jupiter. Dr. Stern is a planetary scientist, a member of the Challenger Center Board of Directors, and the former Associate Administrator of NASA's Science Mission Directorate. He is the principal investigator of the New Horizons mission to Pluto. Dr. Stern has recorded a series of space science podcasts for us this year. Thank you and welcome, Dr. Stern.
Thanks, Rita. Great to be back.
We have some questions for you about the topic of Jupiter's moons. My first question is about the planet Jupiter, as it is a very different planet from our Earth. Can you explain to us what a gas giant planet is and what are the unique features of Jupiter?
Well, sure. Jupiter is the largest planet in our solar system, but its composition is very, very different from the Earth, the planet that we live on. Whereas the Earth is almost entirely made of rocky things with just a thin atmosphere over our heads that's just a tiny fraction of the Earth's mass and a tiny fraction of the Earth's diameter in terms of the altitude of the atmosphere. Jupiter is mostly made of atmosphere, and that's actually what characterizes these gas giants. They are giant planets in the sense that they weigh dozens to hundreds of times as much as the Earth, and they're mostly all gas. They're made of hydrogen and helium and little bits of other gases, and they're sort of the opposite of Earth-like planets in that there's very little rocky material on a percentage basis. So they're very alien.
How many moons does Jupiter have?
Well, we don't know the answer to that. So far, 63 moons have been discovered orbiting Jupiter, and most of those are pretty tiny, measuring just a few miles across. The largest ones, though, are the size of planets, and we expect that more moons will be discovered. Particularly, we know that we haven't completed finding all the tiny moons of Jupiter because we couldn't detect something that was, say, 100 yards across that far away yet. As time goes on, Jupiter may have many more moons discovered, perhaps another 63.
Doesn't Jupiter also have rings, and what are these made out of?
Jupiter does have rings, just like all the giant planets. The small moons that orbit Jupiter sometimes get hit by micrometeorites or even by larger things that kick material off the surface that blast it into orbit around Jupiter. And that material disperses into a ring around its orbit. And so the rings of Jupiter, which are very tenuous, are made of little tiny bits of dust and dirt blasted off the moons of Jupiter.
The first important moons of Jupiter are the 4 Galilean moons, the ones that Galileo could see with his telescope back in 1610. So let's start with those. They are large and they're interesting. Can you tell us a little bit about the orbital resonance that affects 3 of the inner Galilean satellites, Io, Europa, and Ganymede? This causes them to experience tidal heating and makes them very unusual.
Well, that's right. And Io, Europa, and Ganymede are all the size of planets. They orbit Jupiter. In fact, I call them planets. They if you pulled up in a spaceship around them, you would say I'm orbiting a planet. They just happen to be planets that orbit another planet, just like some stars orbit other stars. And these three moons, Io, Ganymede, and Europa, orbit in rather close to Jupiter and interact with each other because their orbital periods, the amount of time it takes them to make a circuit around Jupiter, are related to one another. When one goes around one time, the others go around even number multiples of that. So, for example, if Ganymede goes around once, Io may go around exactly 3 times. And that means that they lap each other in a predictable way and interact gravitationally because they make rather close approaches on a regular basis of one another. The fact that their orbits are even number multiples in time is the basis of this funny word resonance.
So let's start with Ganymede that experiences this orbital resonance and may have some fluxing of the planet. I guess some scientists think there may be a saltwater ocean that exists below Ganymede's surface because of this. Is that true?
You're right. There's indirect evidence that leads us to conclude, in fact, that not only Ganymede, but also Europa, who's in the resonance, and Callisto, another moon of Jupiter, almost as large as the planet Mercury, all have saltwater oceans in their interiors. Pretty amazing, huh?
Speaking of Callisto, it kind of looks like Mercury. In photos, you can see it is very heavily cratered. What does that mean about that planet or
Yeah.
moon?
It's a planet. You know, Callisto, its surface must be very old, and it must have either no or only very slow internal geological processes because it retains all those craters made from very long ago. And as you say, it's about the size of Mercury. In fact, Callisto is about 99% the size of Mercury, almost exactly the same as the size of Mercury.
And Callisto may also have this subsurface ocean of liquid water.
That's right, and it has even has a thin atmosphere.
Oh, okay, let's move on to Europa, one of my favorites. This large moon, many people have seen. It has the giant icy cracks on its surface. So it too may have liquid water under this icy crust?
Well, that's right. We think so. The surface of Europa is the polar opposite of Callisto. It's very young. There are almost no craters on the surface, indicating that it's very, very active. And there are geological features on the surface that look very much like ice flows and fissures where liquid has extruded. And when we measure the composition of that liquid, we find frozen water ice. And that, along with other kinds of evidence, lead us to believe that at very shallow depths, perhaps as little as just 10,000 feet below the surface, a couple of miles, there may be this giant global ocean, which is exciting because it's so close to the surface that future spacecraft might someday be able to actually go there and drill into the surface and get to the ocean and explore it.
It's very exciting. I wonder what they'll find. Let's move on to Io, a moon that has major active volcanoes. Such an interesting place. Interesting to look out, pretty colors. Can you tell us a little bit about that?
Well, sure. Io, which is the innermost of the four satellites that are the size of planets and that were discovered by Galileo, is the most volcanically active body in the solar system. It's about 100 times more volcanically active than the Earth, and it would be a very dangerous place to be, not only because its surface composition is poisonous to us, but because temperatures are very hot wherever the volcanoes are, and there are always mini volcanoes going off and spewing these poisonous materials around the surface.
It's so very different from the other three moons.
It is. It's thought that this orbital resonance we talked about has heated Io to such an extent that it's driven all the ice that it once had away, basically evaporated the ice off of Io and dried it out, and now it's just this sort of volcanic cinder that's left over from that process and which is constantly being churned and kneaded and heated. Really a hellacious place.
Wow. What other moons of Jupiter have distinctly interesting features and might be good places to go exploring?
Well, one that I'm particularly interested in orbits even closer to Jupiter than Io does. It's called Amalthea. It's sort of shaped like a potato, and it's only about 100 kilometers in length, so it's a small moon, not planet-sized, but it's bathed in the very intense radiation field near Jupiter, as are Io and Europa, which makes them very hard to explore. But Amalthea seems to be coated in material that came off of Io. It has the same color as the stuff coming out of Io's volcanoes. And it also seems to have some sort of debris orbiting with it, perhaps, again, from impacts onto its surface that are creating the beginnings of a ring.
If you could pick one moon of Jupiter, just one, to visit, which one would it be and why?
I think I would answer that question by saying I would like to visit Callisto, which is the largest and outermost of the Galilean satellites. It's very old, and I think it has a lot to teach us about the early days of the solar system, but also because it's the farthest out of the planet-sized moons of Jupiter. It's the safest to go to. It's least bathed in dangerous radiation. That's the one I would like to visit.
Well, thank you for joining us today and telling us about the interesting moons of Jupiter. And we hope to be talking to you again soon.
Thank you very much. It was a lot of fun.